we're talking about naming compounds and writing the formulas for compounds. And so it's important, again, to be able to identify if it's a metal or a nonmetal, because that determines how we're going to name the compound or how we write the formula for the compound. So first one we're going to look at is ionic bonds, because that's the most involved. It's probably the hardest. Today we're going to look at how to write names from the formulas of ionic bonds. So ionic bonds happen between metals and nonmetals. Now, metals lose electrons to form cations, which is a positive charge. Nonmetals gain electrons to form anions, which is a negative charge. Okay, so the metals will always lose electrons, and the nonmetals will always gain electrons. Okay. So remember, cation is positive charge. To remember that, is cat has a T in it, that's a plus. Positive charge, so cation. Whereas anion is a negative charge, so think of anti, anion, negative. Okay. Next, we're talking about monoatomic and polyatomic ions. You need to be able to know you need to know the definitions of cation and anion. And you need to know the definitions of monoatomic and polyatomic. Okay, so look under your desk and take out the blue and the pink sheet. Okay, the blue sheet is your periodic table. The pink sheet is polyatomic ions. Now, monoatomic ions are ions made from one type of atom, okay? So monoatomic ions, that means just one type of atom. Now, in a formula, you may have two sodiums, but it would still be considered a monoatomic because it's just sodium. Whereas polyatomic ions is made up of more than one type of atom that have an overall charge. So the pink sheet is your polyatomic ion sheet, okay? You have a quiz on this next Wednesday. All right, I gave this to you before the break. It's been on Canvas. You had to play a game on Canvas with these polyatomic ions. Okay, you have a quiz next Wednesday on these. Okay, the list is on Canvas, and I think there's a Quizlet link on there also with these. Okay, you need to be able to tell me the name and the formula and the charge, because they all matter. Okay, so if you're going from the name of the compound to the formula compound, you got to know the formula. If you're going from the formula of the compound to the name, you got to know the name, okay? You got to be able to identify that. Now, polyatomic ions are molecularly bonded. They're covalent bonds. So if you look at ammonium, the first one, ammonium, NH4, positive 1, that is a molecular compound. NH4, that's covalent bonds between the nitrogen and the hydrogens, but the overall molecule is charged. The overall molecule has a positive 1 charge. Therefore, it's going to participate in ionic bondings, okay? But poly means many, right? And so that means there's more than one type of element. There's a nitrogen and a hydrogen. Or for acetate, there's a carbon, hydrogen, and oxygen. So that's the difference between monoatomic and polyatomic. So monoatomic is just the element, whereas polyatomic is more than one type of element. Now, monoatomic cations and monoatomic anions. I'm going to let you all write this down, and then we're going to look at that. All right, so monoatomic cations, these are metals. So if you see monoatomic cation, that means the metals of the periodic table. The name stays the same. So when we are naming compounds, monoatomic cations, meaning one type of element that's positively charged, we're going to name it, or the name is going to stay the same. So an example would be if I have sodium with a positive 1 charge, we're going to just call it sodium, the sodium ion. Now, monoatomic anions, these are the nonmetals of the periodic table. If a nonmetal is charged, it's considered a monoatomic anion. For these, when we're naming them, we're going to change the ending to I. So here we have chlorine -1. Instead of just calling it the chlorine ion, we call it the chloride ion. Okay? Now, polyatomic cations and anions, the name is going to stay the same, and it doesn't matter. It's always going to stay the same. So NH4 positive is ammonium, NO3 negative is nitrate. And again, it's very important that you memorize these. Okay, first, so you'd be able to tell if it's polyatomic or monoatomic in a compound. And because you're going to be using them over and over and over again. You're going to be using them a lot. So you got to be able to tell the difference between those. So here we're going to name the following ions. So Br -1. Now is bromine a polyatomic ion? No. Okay, so it's not going to be on that pink list. All right. Now, is bromine a metal or a nonmetal? Non-metal. So if it is a monoatomic, meaning it's not a polyatomic ion, non-metal, we're going to change the ending to I. So this is the bromide ion. Okay, bromide ion. Now, Ca positive 2, that's calcium. Is calcium a polyatomic ion? No. If it's not on this list, it's not a polyatomic ion. Now, there are more polyatomic ions than is on this list, but I'm not going to give you one that's not on the list. So, calcium's not a polyatomic ion. That means it's monoatomic. Now, is calcium a metal or a non-metal? Metal. It's a metal. Now, metals do not change their name, right? So, it's just going to be the calcium ion. Okay, calcium ion. Now, NO3 -1, is this a polyatomic ion? No. There are 2 ways we can tell it's polyatomic. One is because it has both nitrogen and oxygen, okay, more than one type. Or 2, you can look on your sheet. You find NO3 on there. What is NO3? Nitrate. Nitrate. Now look right underneath it. Right underneath it, there's nitrite. If you look at the formulas, the difference between nitrate and nitrite is that nitrate has 3 oxygens, nitrite has 2 oxygens, okay? Ates will always have 1 more oxygen than ites. You'll see that again in sulfate and sulfite. In this case, sulfate has 4 oxygens, sulfite has 3, and then phosphate and phosphite, phosphate has 4 oxygens, whereas phosphite has 3. Then chlorate and chlorite also do that at the top. Chlorate has 3, whereas chlorite has 2. Okay, so that's just something to point out with the 8s. So this is the nitrate ion. You don't change the name of a polyatomic ion. So nitrate ion. Now this is an I. I -1 is iodine, a polyatomic ion. Is it on this list? No. No. Okay. So that means, is it a metal or a non-metal? Non-metal. Okay, so if it's not a polyatomic ion, if it's a non-metal, I've changed the ending to iodide, or changed the ending to iod. So it's the iodide ion. Now, one thing I do want to point out is, say I had nitrogen -3. Okay, nitrogen's not a polyatomic ion; it's a non-metal. So you would name it the nitride ion, okay? There's not much difference between these names, right? There's nitrate. Nitrate is going to be NO3 -1. Nitrite is going to be NO2 -1. And the nitride is just going to be nitrogen. So you got to be able, first of all, memorize those polyatomic ions, and then know that IDE means that it is just the element. Okay, so if it ends in IDE, it's just the element, it's just nitrogen. If it's phosphide, it's just phosphorus. It's not phosphate or phosphite. Okay? If it's sulfide, it's just sulfur. It's not sulfate or sulfite. Okay? All right. Let's look at the next one. So name the following. Now we're putting them together. Okay? One thing I also want to point out is that, remember, ionic compounds are, the actual formula is a balance of the charges. Do y'all remember doing this? With the calcium, had 2 electrons. Chlorine had 7, right? And so calcium's going to give 1 electron to chlorine. That makes this -1. And then we have to add another chlorine with 7. So calcium's going to give its second away, and that's going to make this chlorine -1 and this calcium +2. Okay? Now, when I'm writing the formula, though, I have 1 calcium, 2 chlorines. I don't write the ions, right? I don't show the charge because they canceled out. Here, I have an overall charge of +2, whereas here, I have 2 -1s, or an overall charge of -2, right? +2 plus -2 is 0. So these charges have canceled out. Okay, so these are still involved with ions. These are still ions, the barium ion, the fluorine ion, or fluoride ion, you'll see in a second. But when they're in a formula, their charges are canceled out. Okay? Now, when looking at the formula, we can identify if it's ionic or covalent by looking at the first element. My first element here is barium. Okay, barium is a metal. If it starts with a metal, then it's an ionic compound. If it starts with a nonmetal, it's a covalent, except when it has ammonium. Remember, ammonium is the only polyatomic ion that's positively charged. So if it starts with an H4, it's an ionic compound. Okay, so let's start with barium. We have barium here. That's a metal, right? Not a polyatomic ion, so we're not going to change the name. So it's just going to be barium. Okay, now we also have fluorine here. We have an F. Fluorine's not a polyatomic ion. Okay, it's a non-metal. So for non-metals, we have to change the ending to I. So it's going to be barium fluoride. Okay. Now my next one, I have K3PO4. K is potassium. Okay. Potassium is a metal. And so we're not going to change its name. It's just going to be potassium. Okay, potassium. Now, PO4, that is a polyatomic ion. And also, I knew to stop after potassium because I saw that PO4 was a polyatomic ion. Again, another reason you got to memorize these. If you can't even identify if it's polyatomic or not, you're going to have a hard time with this unit. It's going to be really hard. Okay, PO4 is a polyatomic ion. That's phosphate. So it's just potassium phosphate. We're putting them together. Now NH4Cl. So like I said, NH4 is a polyatomic ion. It's the positive charged polyatomic ion. This is ammonium. Ammonium. Okay. Now Cl, that is not a polyatomic ion. It's a non-metal, right? So what do we do to the ending? Change it to I, so it'll be fluoride, because it's a non-metal, fluoride. Now here we have strontium. Strontium is a metal, and so we're just going to write the name. Now ClO3 is chlorate. Okay, that's a polyatomic ion. So it's just going to be strontium chlorate. But one thing I want to point out here also is how many chlorates do I have? I have 2 chlorates, okay? Remember what makes chlorate chlorate? It's the number of oxygens, right? If the number of oxygens change, that means it's no longer chlorate. So if you have more than 1 polyatomic ion, you're going to put it in parentheses. So here I have 2 polyatomic ions because I needed 2 chlorates to balance out the strontium. Like here, I needed 2 chlorines to balance out the calcium, right? Okay, that's the same thing there. We're going to look at that next class. but I just want to point out that this 2 means I have 2 ClO3s. That 3 is part of chlorate. Doesn't mean I have 3 chlorates. Okay. All right, now transition metals. Y'all look on your periodic table. Where are the transition metals on the periodic table?
In the middle.
In the middle. So groups 3 through 12, right? That's the transition metals. Now post-transition metals. Post means after. So the post-transition metals are the metals that are in the P block, okay? This is excluding aluminum, what we're about to talk about. Aluminum's always going to have a positive 3 charge. But y'all look at iron. Y'all see iron has a positive 2 and a positive 3 charge, right? So we said groups 1 has positive 1, group 2 has a positive 2, group 13 has a positive 3. Y'all remember doing that? Okay. Now we skipped over the D block, and this is why. It's because the D block, the elements in the D block can have more than 1 charge. Now there are exceptions. There's 4. We're going to write them down in a second. But the rest of them, the elements in the D block, the transition metals, and the post-transition metals can have more than 1 charge. It is incredibly important that we indicate what charges it's holding there. Because look here. Both of these have iron in them. Okay? But the iron in each of these is different. This is iron, positive 2. This is iron, positive 3, right? Do y'all see the difference there? Iron, positive 2 is almost clear. Okay, got a yellowish orange tint. Whereas iron, positive 3 is opaque. You can't see through it. And it's got this kind of rusty orange color, okay? You can visibly see how different iron 2, iron positive 2, and iron positive 3 are, right? So when we're writing the names for transition and post-transition metals, we have to tell them if it's a positive 2 or a positive 3 for iron. Some of these can have up to 4 different charges. If you look at manganese, number 25, it can have a positive 2, positive 3, positive 4, or positive 7, okay? A lot of these can have a lot more charges. And this isn't exhaustive. So this periodic table may not show multiple charges for an element that does have them. Okay, it's just according to the periodic table. This is just the one we're going to use in class, okay? So the way we show how which charge is happening in the element, if it's going to be positive 2, it's going to be positive 2 or positive 3, is we write a Roman numeral. So do y'all remember the Roman numerals? Y'all remember doing them? Okay, we're going to go over them in a second. But I'm going to have y'all write this down right now, and then we'll look at that. So transition and post-transition metals can have more than 1 charge. All right, so transition, post-transition metals can have more than 1 charge. There are exceptions. Silver, zinc, cadmium, and scandium will always have 1 charge, okay? So those don't require a Roman numeral, just like groups 1 and groups 2 do not require a Roman numeral. If you have an element from group 1, say you have sodium, you don't have to do what we're about to do. You just name it like we just did, okay? So they require Roman numerals to tell me what charge it's holding. So Roman numeral 1 is going to be an I. Roman numeral 2 is going to be an II. 3 is going to be an III. And then 4 is an IV. Okay? Now, I'm not going to go above 4. We're not going to have anything that's above 4. Manganese says it can have a positive 7. We're not going to deal with that. Okay? So, and again, remember the charges on an ionic compound must cancel out. Okay? We got to keep that in mind. So here's our example. We have iron sulfate, right? Now, I'm going to write up here iron, and I'm going to leave a space, sulfate. Now, this could be iron 2 or iron 3. Again, 2 big differences. This is iron 2. This is iron 3. completely different properties, okay? So we've got to determine which one of these is it. Is it iron 2 sulfate, iron 3 sulfate? Okay? So to do that, oh, and one more thing, the Roman numeral is the charge of one of those ions, of one iron. So iron positive 2 means that one of my irons has a positive 2 charge. Iron positive 3 means that one of my irons has a positive 3 charge. So to determine the charge on the iron, we have to use the charge of the sulfate, okay? Because we don't know what charge the iron's holding here. You can't just look at this formula and say, okay, iron's holding a positive 1 because it does, or a positive 2 because it's not showing it. So we know that sulfate has what charge? If you look on your polyatomic ions list, it'll tell you. Negative 2. Okay, sulfate has a negative 2 charge, right? Now, how many sulfates do I have? 3. Okay, remember, SO4, the 4 is part of sulfate. There are 3 sulfates. Okay, it distributes like it does in math. 3 sulfates. So what this means is I have 3 SO4s, each holding a negative 2 charge. That's what that means. Okay, SO4 negative 2, SO4 negative 2, SO4 negative 2. If I have 3 sulfates, each holding a negative 2 charge, my overall negative charge would be negative 6, right? So I take negative 2, the charge of sulfate, multiply by how many sulfates I have. My overall negative charge is negative 6 because I have 3 negative 2s. Do y'all see that? Okay. Now, here's where we get to the iron. If my overall negative charge is negative 6, and the negative and positive are supposed to cancel out, what's my overall positive charge? 6. Positive 6, right. So, since the overall negative charge is negative 6, the overall positive charge is positive 6 because those charges must cancel out. Okay? Now, that is not the charge of one iron. I want the charge of one iron. That's the charge of 2 irons together because I have 2 irons in my problem. Do y'all see that? So what this means is I have 2 irons, each with some kind of charge, and they equal overall positive 6. So to find the charge of one iron, which is what I'm going to use in my name, I divide it by 2 because I have 2 irons, and that gives me a positive 3. So we have 2 irons, which we know that their charges multiplied together equal positive 6, not multiplied, I meant added. So we need to divide by 2 to get their individual charges. So positive 3, positive 3, okay? Positive 3, positive 3. It gives me positive 6. So our answer here is positive 3. Now what this answer tells us, it tells me what Roman numeral I need to use. It tells me here that I'm looking at iron 3 and not iron 2, okay? So I'm looking at iron 3 sulfate. So when I'm writing the formula, my Roman numeral is going to be in parentheses after the iron. So this is going to be iron 3 sulfate. And again, it's incredibly important you write that Roman numeral because there's a big difference. Especially if you're going into medical school or pharmacology, you need to know the differences between these two because they could do 2 very different things. First of all, they look completely different, and they react differently. Iron 2 may react with something that iron 3 does not, okay? So you've got to be able to tell the difference between those. Now remember, this only applies to transition metals and post-transition metals. If I have a metal in group 1 or group 2, I don't have to use my Roman numerals because they're always going to have positive 1 or positive 2 charge. And aluminum. Aluminum is always going to have positive 3. But if they're transition metal or post-transition metal, you've got to do this. Okay, so let's look at some examples. So here I see iron and chromate. Now I know iron, I'm going to put this iron chromate, but I know that iron is a transition metal, right? That means it's going to hold more than one charge. We got to figure out that charge. We got to put that Roman numeral there. So chromate, what's chromate's charge? You'll look on your polyatomic ion list. Negative 2. Now, how many chromates do I have? 3. I have 3 chromates. So that means my overall negative charge is negative 6. Okay? We had to calculate the overall negative charge to get the overall positive charge. What's the overall positive charge? 6. positive 6. Okay? Now, is that the Roman numeral that I'm going to use? No. Okay? Because I have 2 irons. That's the overall positive charge, but I want the charge of 1 iron. So positive 6 divided by 2 is going to give me positive 3. Now, divided by 2 because I have 2 irons, right? This is my Roman numeral. Positive 3 is my Roman numeral. So, in my name, I'm going to put iron 3 chromate. So again, it's important that you tell me which iron we're using. Okay. Next one, we have tin and carbonate. So SN is tin, T-I-N. Okay. SN is tin, like a tin can. And then we have carbonate. Now, tin is not a transition metal, but it is a post-transition metal. If y'all look on your periodic table again, you'll find tin, SN, it's number 50. Yeah. Number 50, you can have a positive 2 or a positive 4 charge. So we got to figure out what charge this tin is holding. So carbonate, CO3, what's carbonate's charge? Look on the polyatomic ion list. Negative 2. Now how many carbonates do I have? 2. So that means my overall negative charge is going to be negative 4. Okay? Negative 4. Now, if my overall negative charge is negative 4, what's my overall positive charge? Positive 4. Now look, we only have 1 tin, so we'll divide it by 1 and get positive 4. So in this case, my overall positive charge is also the charge of 1 of the tins. That's because I only have 1, right? So this is going to be 10, 4 carbonate. Okay? And again, that 4 means, it doesn't mean I have 4 tens, right? I don't have 4 tens. It means that the charge of 10 is positive 4. Okay, that Roman numeral is always positive. Last one, Cu3P. Now I have copper. Now I have phosphorus, right? Phosphorus isn't polyatomic, and it's a non-metal, so we have to change the ending of that to what? Phosphide. Change it to IDE. Phosphide. Now, again, if you look on your periodic table, copper is a transition metal. Copper can have a positive 1 or a positive 2 charge. So we got to figure out what's happening here. So we start with phosphorus, or the phosphide ion. Now, phosphorus, if you all look on my big periodic table, I have it written up there. Phosphorus is in group 15, right? At the top of group 15, you see a negative 3. That means all those elements hold a negative 3 charge, except antimony and bismuth, but that's a metal. Anyway, so negative 3. Now, I only have 1 phosphorus, right? Okay, so that means that my overall negative charge is negative 3. Now, if my overall negative charge is negative 3, what's my overall positive charge? Positive 3, right? Positive 3. Now, is that the charge of the copper? No. No, I have 3 coppers, right? And I want the charge of 1, so I got to divide by 3, and that gives me a positive 1. Okay, and you'll always get whole numbers here. It's never going to be, like, you're never going to have half a charge. Okay, so we do copper 1 phosphide. And again, this only happens with transition and post-transition, right? If you have a metal in group 1 or group 2, you do not need to do this. You do not need the Roman numerals. Okay, you only need them if it's a transition or a post-transition. Okay? Because if I give you sodium carbonate, it's not going to have a Roman numeral in it because it's assumed you know that sodium's always going to be positive 1. Okay? All right. So now